Hi everyone, welcome back. Hope you are doing good. This is Mahesh. In this video, we will look into few of the examples on computing time complexity. So before starting, let us try to understand the types of algorithms. There are basically two types of algorithms we have. One is the iterative ones, iterative algorithm, and another one is recursive algorithm. So what are iterative algorithms? Basically the algorithms which use loops like for loop, while loop, and do while loop. These are basically iterative algorithms, and recursive algorithms are nothing but the functions that call itself. So basically in recursive algorithm, what happens? The function calls itself to solve a particular problem. We will look into recursive algorithm in the upcoming videos. In this video, we will look into the iterative algorithms first, and let us look into the first example. So this is our first example. Here what is happening? I is starting from n and I is getting divided by 2 on every iteration, and I stops when I becomes equal to 1, or it iterates unless I is greater than 1. So this is not a straightforward one, right? So we have seen a simple straightforward loop where I starts from somewhere 0 or 1 and it iterates until n. So for that we have calculated that its order is of order n, but this is not that way. So how to analyze this one? Let us see. So basically let us try to analyze the values of I. So initially it is n. In the next iteration it gets divided by 2. In the next iteration again this gets divided by 2, that is equal to n divided by 2 square. And in the next iteration it gets divided by again 2, that becomes n by 2 to the power 3, that is 2 cube, and it continues n divided by 2 to the power 4, and so on. So how long it continues? We don't know how long it continues. So let us assume it stops when our n becomes n divided by 2 to the power k. So what exactly is this n divided by 2 to the power k? We have seen here, right? Our I stops when it becomes equal to 1. So that means our n divided by 2 to the power k becomes 1, it stops. That's what we understood. So now we got a proper equation. So if we solve this one, n equal to 2 to the power k. Now if I apply log on both sides, log to the base 2, then it becomes 2 to the power k. So that is nothing but k log 2 base 2. So this is 1. So that implies k equal to log n to the base 2. So we got the order of this particular equation, which is of order log n to the base 2. This is how we compute the time complexity for such loops. So this is pretty much same when we compare it with one more loop, right? I mean, we have seen in the previous video for I equal to 1, I less than n, I is getting incremented by 2. So this is the loop. For this also, the order is of log n to the base 2. So this is pretty much same. This is starting from 1 and incrementing by multiplying with 2, but this is starting from n, decrementing by dividing it by 2. So that is the difference here. Otherwise both the loops are somewhat similar. Now let us look into another example. Second example. Here what is happening? Our I is starting from either 0 or 1. Let us consider it is starting from 1, and I into I is less than n, and I is getting incremented by 1. So now if you see here, it is nothing but I square is less than n. So this loop iterates until unless I square is less than n. When I square becomes n, this loop stops. So it means this is pretty much straightforward, right? I equal to root n. That is nothing but it is of order root n. It's of order root n. So this is also pretty much same. I mean, I have just used I square is less than n. So both the loops are similar here. So this is one more example. Let us look into another example now. So this is our third example. Here what is happening, we have two consecutive for statements which execute one after the other. So for that, let us first solve the first for loop. So here what is happening, so I is starting from 1 and I is getting incremented by 2, I mean getting multiplied by 2 on each iteration. Then it executes until unless I is less than n. So it means I is, this stops when I becomes n. But what is happening inside? For each iteration, p is getting incremented by 1. So it means this particular loop executes for log n to the base 2 times. So if this loop repeats so many times, our p gets incremented so many number of times. So at the end of this particular the loop, our p value becomes log n to the base 2. So this is our first equation. Now when it starts the execution of the second statement, we can see here j is 1 and j until j is less than p, it executes, and j is getting incremented by j into 2 every time. So it means it is of or again order log but not n, it is p because it executes until unless j is less than p. So it is log p to the base 2. But we have computed the value of p here. So it means it becomes log of n to the base 2. So its order is log n. The order of this particular for statements is log n. Now let us look into another example. So this is our fourth example. Here what is happening, we have two loops but which are nested. So first loop runs from I equal to 0 until I less than n, and I is getting incremented by 1 on each iteration. It means it runs for n number of times, correct? Now if we see our second loop, it starts from 1, it runs until j is less than n, but j is getting incremented by j into 2. Okay, so it means it executes for log n to the base 2. Okay, this second for loop executes for log n to the base 2. But if you see this statement, it executes for log n to the base 2, but our first loop executes for n number of times. For each time, the second loop executes for so many number of times. That's why we have to multiply it with n. So its order is of n log n. This is how we can compute the time complexity for such loops. Okay, let us look into one more example now. So this is our fifth example. Here what is happening, our I is, there are basically three for loops. The first loop runs from 1 to n, but the second loop runs from 1 until j is less than or equal to I. What it means, if I is 1, then it runs only one time. If I is 2, then the second loop runs 2 times. If I is 3, the second loop runs for 3 times, and so on till n. So whenever I becomes n, this particular loop runs for n times. Now if you see the third loop, it starts from 1, it runs until k is less than or equal to 100, and k is getting incremented by 1. So it means it runs 100 times. Let us try to compute the time complexity for this loops I and jk So when our I value was 1, our j executed one time. So k executed for 1 into 100 times. Okay. When our I value is 2, our j executes 2 times and our k loop executes for 2 into 100 times. When I is 3, j executes for 3 times and k executes for 3 into 100 times. When our I is 4, j executes for 4 times and our k executes for 4 into 100 times, and so on. When our I reaches n, our j also runs for n time and our k runs for n into 100 times. Okay. So now if we want to get the time complexity, then we need to sum up these numbers. So 1 into 100 plus 2 into 100 plus 3 into 100 plus 4 into 100 and so on plus n into 100. Okay. So now what we can do, we can take out 100 common. So if I take out 100 common, it becomes 1 plus 2 plus 3 plus 4 plus and so on plus n. So 100, this is nothing but sum of n natural numbers. So this will be 100 into n plus 1 divided by 2. So 2 ones are 50. So this becomes 50 n square plus 50 n. So we only consider highest degree polynomial. That's why it is of order n square. If we see here, there are 3 loops, but we are getting of order n square. How? Because if you see this particular loop, it does not increase based on the value of n. So whatever be the value of n, it always runs for 100 times. So it does not increase if we increase the value of n. That's how this is somewhere of some constant time. But this runs for n time, this runs for close to n time. That's when it becomes of order n square. This is how, with a naked eye, we can try to compute the time complexity for this kind of loops. That is it for this video. We will look into some more examples in the upcoming video. Thanks for watching the video.